Hi guys. Today we're going to continue with solving by substitution. In yesterday's video, all of our systems of linear equations were set up in a way where we were ready to substitute right away. They were set up in a way that was conducive to substitution. Today we'll talk about what you should do if the equation is not set up for substitution and how to make it so that you can use substitution on any problem. Here is our first example. In this question, I do not have one of the equations where just the x is by itself or just the y is by itself. But the directions still say I have to substitute. And it's really important that you are practicing all the different ways of solving. So I am going to use substitution to solve this. What I need to do as kind of like a pre-step before I can substitute is I need to choose one of my equations and I need to choose one of the variables that I want to get by itself. Now you can choose whichever equation and whichever variable you want. However, there are some choices that are just a little bit easier and nicer to work with. And so I'm going to help you out a little bit with that. So when you're choosing which equation and which variable to get alone, you want to choose a variable that has no coefficient, no number in front of it. And if you can even go one step further and have a variable that's positive with no number in front of it, that's your best case scenario. If you are choosing to solve for a variable that has a number in front of it, one of the steps of solving will be dividing by that number, and you run the risk of creating fractions. And so again, if you can choose a variable without a number in front of it, you won't have to deal with fractions, and it'll just make your life a little bit easier. In this scenario, I'm definitely not going to choose to get the letter x by itself, because both of the x's have a number in front of them, a coefficient. And that's going to create fractions, and that is my nightmare. I don't want to deal with fractions. So instead, I'm going to choose to get a letter y by itself. Now, if I have a choice between a positive y and a negative y, the positive y is going to be easier to get alone. If you do choose to get the negative y by itself, you'll just need to make sure, as a final step, that you divide everything by -1 to get rid of that negative sign. But if I make a choice to do the top equation and get the letter y by itself, it's one step. All I have to do is minus the 2x to the other side. Now, my problem is set up for substitution. If you need to reset up the problem for substitution, you also need to be very careful when you are substituting this in. You want to make sure that you don't accidentally substitute this problem back into the equation that it was created from. You want to make sure that you're taking this new equation and plugging it into the equation that you have not used yet. So I will be taking the 7 minus 2x and plugging it in to this y down here. Now, whenever you're plugging it in, especially if it's an adding or subtracting problem, you want to enclose it in some parentheses. Because on these problems, you're probably going to need to do some distributing. And if you don't write parentheses, you might forget to distribute. In this particular example, I will be distributing that negative sign or distributing a -1. That will change it to a -7. And here's the important one that we don't want to forget. It's also going to change it to a plus 2x. So if I had to guess where a mistake would happen on these problems, it would be forgetting to distribute a negative sign. Very common mistake that we want to try to avoid. Now I'm going to solve for x. So we're going to combine like terms. We're going to add 7 to the other side, and we're going to divide by 5, and I get x equals 3. Now don't forget, this is not the final answer. All of these questions must have an answer that is an ordered pair. So I found half my answer, but I do need to keep going. When you're choosing to substitute the x equals 3, you actually have now 3 choices of where you want to substitute. You could plug it into the first equation, where the x is, and solve for y. You could plug it into the second equation, where the x is, and solve for y. Or you could plug it into this new equation that you created and solve for y. The only place you don't want to plug it in, you don't want to plug it in down here, because we need to solve for y, and this equation doesn't even have a letter y in it. So you want to make sure that you're plugging the 3 into an equation that has both an x and a y. When I'm choosing, I always choose the one that says y equals, because it's just a little bit less work. So I'm going to plug it into that one. Again, it doesn't matter which one you plug it into, you should still get the same answer, no matter which equation you use. This I can do in my head. 2 times 3 is 6, 7 minus 6 is 1. And now I'm ready to write my final answer, which is an ordered pair. Remember, order is alphabetical, so my final answer is 3, 1. Now, this is the only example I have of this type of problem, but if you'd like to try some more before you start your homework and you want to be able to check your answers, I have some try on your own that you can try. So why don't you go ahead and take a second, pause the video, and try these two problems. All right, I hope that you paused it and tried these two problems. On the first one, the variable that is the easiest to solve for, to put it into the notation that you need for substitution form, would be the letter x in the first equation, because it's the only variable that doesn't have a number in front of it. To solve for x, all you would have to do is minus the 2y, and then you would be ready to substitute. Here's the answer for the first one. For the second one, you have two equally equivalent options of what to solve for. If you want, in the first equation, you could solve for x. Now remember, when you're solving for a variable, there can't be anything in front of it. So at some point in time, you would need to get rid of that negative sign. You could minus the 4y to the other side and then divide by -1. Or you could just add the x to the other side, and then the x would be by itself. Your other option, equally as easy or difficult, depending on how you think of these problems, would be to solve for this y, because that y does not have a number in front of it. So again, you could minus the 3x and then divide everything by -1, and you would get that y by itself. Now, this problem was pretty tricky, so I wanted to show you that you're not always going to get nice whole numbers for your answers. If you get a decimal that takes up your entire calculator, do not write it as a decimal, write it as a fraction instead. So in this problem, my answer is 280 over 11, comma, 70 over 11. So it is possible to get fractions, it is possible to get decimals. You're not always going to get whole numbers. So don't worry if you get a fraction or a decimal. That doesn't mean that you're doing it wrong. It just means that that problem does not have a pretty answer. This concludes today's video.